The Richter scale and the modern moment magnitude scale are logarithmic. Each whole number increase represents a 32-fold increase in released energy. A magnitude 9.0 earthquake, like the 2011 Tohoku event, is devastating. A magnitude 10.0 is not merely one step higher. It is an event that borders on the physically impossible based on the geological constraints of our planet. To generate a magnitude 10 earthquake, a fault line would need to rupture continuously for approximately 2,500 kilometers, a distance spanning from Mexico to Canada, and slip by dozens of meters instantaneously. Earth does not possess a single continuous plate boundary long enough to easily facilitate this. However, if such a rupture occurred, the physics of the event would redefine our understanding of planetary dynamics. The initial shock and P waves. The onset begins with the arrival of P waves, or primary waves. These are longitudinal compression waves that travel through the Earth's interior at speeds exceeding 6 kilometers per second. In a magnitude 10 event, the initial jolt would be strong enough to throw unanchored objects, vehicles, and even buildings into the air, a phenomenon known as precipitous acceleration, where upward ground motion exceeds the force of gravity. Following the P waves are the S waves, or secondary shear waves. These move the ground perpendicularly to the direction of the wave's travel. In a magnitude 10 scenario, the displacement would be so extreme that the ground would appear to behave like a fluid. Solid rock and soil would undergo liquefaction on a continental scale. High-rise structures, designed to withstand lateral forces of a magnitude 8 or 9, would face stresses that exceed the structural integrity of steel and reinforced concrete. The duration of the shaking would be unprecedented. Not the usual 2 to 5 minutes, but potentially lasting up to 30 minutes as the massive fault line continues to unzip. The Great Rupture and surface waves. As the seismic energy reaches the surface, Love and Rayleigh waves begin their transit. These surface waves cause the most visible destruction. In a magnitude 10 event, the Earth's crust would ripple in visible undulations, with the ground rising and falling by several meters. The energy released would be roughly equivalent to 10,000 gigatons of TNT, or the simultaneous detonation of hundreds of thousands of nuclear warheads. The planetary resonance would be profound. A magnitude 10 earthquake would cause the Earth to ring like a bell, a phenomenon known as free oscillation. These vibrations would be detectable by seismographs for weeks and could potentially alter the Earth's polar motion and the length of a day by several microseconds due to the massive redistribution of crustal mass. Global consequences. Tsunamis and landslides. The most lethal secondary effect would be the megatsunami. If the rupture occurs along a subduction zone on the ocean floor, the vertical displacement of the water column would be massive. Unlike standard tsunamis that reach heights of 10 to 30 meters, a magnitude 10 event could generate initial wave crests exceeding 100 meters. These waves would travel across entire ocean basins at the speed of a jet aircraft, maintaining enough kinetic energy to inundate coastlines several kilometers inland. On land, the intense vibrations would trigger simultaneous landslides across entire mountain ranges. The stability of tectonic plates themselves would be tested. Large-scale crustal deformation would occur, permanently shifting the position of continents by dozens of meters. In some areas, the ground would drop or rise so significantly that previous topographical maps would become obsolete. Atmospheric and geological feedback. The sheer volume of dust and aerosols kicked into the atmosphere from collapsing infrastructure and massive landslides would be sufficient to trigger a localized seismic winter. Furthermore, the stress changes in the crust could trigger sympathetic eruptions in dormant volcanoes. The sudden movement of magma chambers compressed by the passing seismic waves could lead to explosive volcanic activity along the Ring of Fire. Ultimately, a magnitude 10 earthquake represents the theoretical limit of tectonic destruction. It is an event that would fundamentally reshape the Earth's surface, proving that while we live on solid ground, we are at the mercy of the immense, restless heat engines churning thousands of miles beneath our feet.